Hi everyone, a warm welcome to Mydbops MyWebinar 51. I'm Shiny and I'm also glad to have you all here today. As many of you know, we just celebrated our 50th webinar milestone last time. Today we start our next chapter and we wanted to start it with a very interesting topic. Our goal is always the same, sharing database knowledge with the community. And to lead the session, right, I'm joined by someone very special. He's not just a core member of our team. He is the visionary behind our technical roadmap, our CTO Manosh Malai. Manosh has 15 plus years of experience in building and fixing high-scale database infrastructures. And when a major production system goes down, he's the one who understands the why and how to get it back up. And he has seen how teams struggle when their failover exceeds 15 minutes instead of 15 seconds. And today, Manosh is going to take us under the hood of Postgres HA stack, and he is going to show us exactly what happens between etcd, Patroni, and HAProxy during those 30 seconds that actually matter. And a quick note to the attendees, we are recording this webinar, and we will have a live Q&A session at the end. So please drop your questions in the chat box throughout the presentation. Manoj, we are all eager to learn from you. Let's get started. Over to you.
Thanks, Shani. Thanks, everyone. Hi, welcome everyone for my webinar 51th edition. So today we are going to discuss about etcd, Patroni, and HAProxy. So what is the crucial 30-second failover going to be happen in the Patroni setup? What is the role of Quorum? What is the leadership election? How the traffic routing behave in the 30 seconds is the actual matter, game changing in the Patroni setup. So I'm going to share some interesting insight, what we learned when we are supporting 100 plus clients all over the world. So I hope I'm so excited, same from you guys. Myself, Manosh Malai. I have a 15 plus years of experience in database and an active practitioner in open source technologies, including database and DevOps practices. So why this talk is matter? So when my team reached me where I need to deliver some interesting talk on PostgreSQL, they suggest how to configure our best practices in PostgreSQL. But I believe I like to share my interesting experience with all of you guys. Maybe something you know, something we are new to. So I like to share what I have learned, what I have what I do in Mydbops when client coming to Mydbops. What are the best practices we implement? We help to avoid or reduce the failover time in Patroni. Particularly, Patroni is very interesting high availability feature in PostgreSQL compared to other databases available in the community. Why? Because this is not a monolithic package. That is the beauty. We name it Patroni, but it is the combination of three things. One is proxy, another one is Patroni, finally is DCS. DCS maybe in our case today is etcd. Maybe someone use Zookeeper or someone use console. It's control. So this all component will decide how soon the failover need to happen, how quickly a database engineer can find the problem statement of the failover and come to a conclusion, address the RCA. Those things is very interesting thing I'm going to share. So I like to set everyone have a good mental model before I'm going to start. Basically, people know coming to the Patroni. Patroni is the purpose, do the failover. etcd store the states and HAProxy for the route traffic. What they need to understand, what they don't know, Patroni does when etcd quorum is lost. How leader lock actually expire. This is one of the interesting thing. It's very simple, but it's very interesting to learn. And HAProxy did a
This is good. Hear it.
And what happened in 30 seconds of the detection of TTL leader lock expire and what delay actually come, where the delay actually come, the switchover is going to happen. This is all very interesting. It looks like one parameter change, one simple tuning, but it create a huge number of SLA violations and affect business and those things. So if I need to describe very simply, control flow and failovers became something you observe, not something you engineer. That is very, very strong word I like to put through this mental model. Sorry. So I hope most of us are very familiar with the stack. But anyway, since we are addressing the bigger forum, I like to set up whenever I'm going to address this particular problem statement in the whole talk, you need to see from the application, from HAProxy, Patroni plus PostgreSQL and etc. So HAProxy trusts Patroni, Patroni trusts DCS, the DCS trusts the RAF. If any line of the link break, the entire whole chain will be chaos. It won't differently in each case of the problem. I shared multiple scenario in the upcoming slide. It's going to be very interesting for us. Another interesting thing, since we are talking about draft, distributed system, consensus, so people very basic need to understand about Quorum. So I don't like to go more depth on draft and how it's work and how the election happened, those things. But I like to give one simple thing. Whenever you are designing DCS, any RAF system, the basic important recommendation is keep your DCS, distributed system, distributed config system, whatever else it is, need to be in odd number. If you are going for even, nothing is going to change the same odd number. For example, I'm going to have a 4 node in the raft. Whatever the result I'm going to get in 3 node, the same I will get in the 4 node itself. So because of the quorum and the math behind it, I have shared the formula above. So the majority defined based on the number of node. Don't go with the odd node. It's again the system resource we are wasting in the infra. Always keep it odd number. Don't go with the even. And very important thing, people always confuse. I'm also from the MongoDB background, right? If I have a 3 node, MongoDB is a monolithic stack of entire thing. They integrated the raft and consensus inside the Mongo itself. But in HAProxy, Patroni, etcd stack for PostgreSQL, right? Etcd is totally a isolated different component from the HAProxy setup. So you always, whenever we are speaking with Patroni, you don't need to confuse the etcd node count with the Patroni count or PostgreSQL count or HAProxy count. How many etcd service running inside the high availability system for a particular cluster, that count is matter. You don't need to confuse with the number of Patroni node or PostgreSQL node. Coming to the interesting topic, how the leader lock work. So before going how the leader lock work, I like to explain what is leader lock. If you have a 3 node in Patroni setup, I have one primary in pre-node. That node hold leader lock inside the etcd. Etcd, you know, it's a distributed config system. Etcd will hold some important information. Basically, I will say who are all the nodes, who hold the primary, who is the replica standby. This all configuration hold by the etcd. So when the leader lock is that important, will define who is holding the leader inside the Patroni setup of high availability system. So there is very important subject we need to discuss here, how leader lock work. For example, I have a 3 node, node A, node B, and node C. Node A holding the leader lock, and he is the leader of the Patroni setup. So there is one important parameter in each Patroni node we call as a loop wait. For it is a standard default config is 10 seconds. Every 10 seconds, Patroni will wake up one initiation to do some set of action to make sure I have a leader. So the leader is good, healthier, so I can continue my job as a read replica. So we have a loop wait parameter in each Patroni config. So the default is 10 seconds, as I said. It wake up, first thing it will do, right? It go to the local system. Patroni and Postgres running on the same machine. It will go to local and check Postgres is running fine or not. When the Postgres is running fine, the next thing it go to etcd or any DCS system, check the leader lock is exist, it's not expired. If it is not expired, I have a leader and it come and continue the job as a reader. If that node who is checking whether the leader lock is there, it renew the leader lock token for 30 more seconds and come and continue the role of it. So this is the role of leader lock, and this is the concept of loop wait. So we are going to see more detail in upcoming slide, but this is the basic understanding how leader lock work, how the basic renewal is happening here. In case the leader lock expired, then the race started to choose for, if I have a 2 more node here, then the 2 nodes start participating in the election, and there is the val LSN coming to the picture, and who is having the latest LSN, he won the game and he became the leader, and he created the leader lock for the system. This is different discussion, more detail, but this is what it is. Coming to the leader lock work, few important parameter everyone need to understand. This is the default value. TTL is the leader lock time. Any leader who is going to create a leader lock parameter in the etcd, it's just a record in the etcd, right? So the default is 30 seconds. So the loop wait is 10 seconds. That means every 10 seconds, any Patroni node, it may be a replica, it may be a primary, it check the basic loop, whatever I saw there, whatever we saw there. So the retry timeout, it is one interesting parameter. It's nothing else. Every system will need to have a time pair. So in every loop wait, it connect to the 2 systems. One, it need to connect with the local Postgres. If it try to connect 10 seconds when the timeout is happened, it fail actually. That means the local Postgres is down, then different subject to discuss. That scenario also we included in the slides. If it is connect to the DCS, it's not able to connect the DCS, it consider DCS is failed or something. So we have a 10 second for that. The primary start timeout is very interesting thing. I have a separate. So these are all the important parameter inside the leader lock things. Patroni is not a magical failover, it's a race of lock. Time is everything. This wording is right. So Shiny or my title define that 30 seconds to 15 minutes, whatever else. This parameter help to achieve the very quicker failover system in the Patroni setup. So coming to the HAProxy layer, HAProxy is not check Postgres directly. HAProxy is not going to do anything with the Postgres directly. HAProxy work with Patroni. It's a Python system. It's a REST API enabled system which integrated with Postgres, which exposed in default port. So we will check with the Patroni to see what is the primary. We can define that the synchronous and read replica. So what I'm trying to say here, we have certain parameter in HAProxy also to achieve our failover very quickly, and these endpoints are very important. Every Patroni engineer need to aware about it. So whoever come across the HAProxy configuration in Patroni, right, they are very familiar with one. If you put URL /primary, the URL connection will go to the particular endpoint will go to the primary node to do the read-write operation, and if it is a replica, it goes to the reader node, and those things are coming to the picture. Coming to the interesting point, 30-second window. So Manosh, we have a Patroni setup. So how this 30-second influence the failover time? and how we can tune it in much better way. If you are asking me, we need to redefine this TTL, loop wait time, and HAProxy in turn fail and rise parameter also to get much better realistic RTO time in the HAProxy Patroni setup with include HAProxy etcd and Patroni things. In case we'll consider time 0, the primary is die. So the primary is die, the leader key is still valid in etcd because we are talking multiple times. The loop wait time when start, then only it check everything and update the etcd parameter. So for example, time 0.0, leader is dead, primary is dead. But in etcd, it is valid, TTL count is down. Then 0.9 second, HAProxy failed 3 checks. Then primary markdown connection get killed. Till that time, the HAProxy connection, whatever coming to hit the primary will fail. After 3 retries, because the HAProxy intent parameter is 3 seconds, the 3 second whatever connection is coming and hitting the HAProxy to give the connection for the primary, all the read and write operation for the current primary will fail. Then replica watch leader key, they don't raise it, they still exit. Then leader key expired in 30 seconds. So the leader key expired in 30 seconds, then only the leader race began. And from 31 to 35 seconds, winner runs. This is the command in Patroni, PGCTL, control promote, and those things come into the picture. And HAProxy C2 successful because the rise is 2. Rise is 2, and it will up the new primary, elect the new primary, the new connections will hit it here. So you see that 30 seconds is not actually 30 seconds. It's actually 35 to 45 seconds. Realistically, the new primary got elected. So if we tune this properly, you will get much realistic time between 15 seconds to get your new primary elected and start the game of serving the customer or application without any impact. So we will go by one by one anti-pattern config and everything. Maybe we'll discuss finally with the Q&A topic. So primary start timeout 5 minutes outage because 300 second is the things. One interesting thing in the above config, if you see, primary start timeout is one important parameter in Patroni. What does that mean actually? Patroni and Postgres run on the same machine. Patroni start loop wait. That time the Postgres is down on the node. It wait for 5 minutes. Till that time, every loop time it renew the etcd key. That means the locker key for this down node. It won't allow the other replica to know this node is down. So this is the important parameter. You can visualize the problem statement, what I am trying to say, right? So Postgres is down on the primary node. That loop wait time start. It understands because already I told the initial time it locally checked the PostgreSQL. That time the Postgres is down. It validate the Postgres is down, but the parameter don't allow to inform the etcd the leader is expired. What it do, it renew the key till 300 seconds. Game is changing 300 seconds, and the loop wait time come into the picture. Then renewal is happen. So nearly the time is like 6 minutes of including primary start time, initial loop wait, final loop wait, TTL expire, HAProxy detection. Total is 6 minutes of downtime or 6 minutes outage we saw because of this one parameter. If you fine tune is based on your RTO, you change or you improve your outage time much better. So coming to as in we recommend, right? So we recommend 30 seconds tight but safe, but comfortable margin is 60 seconds for your heavyweight system. You can choose the right value based on your use case. I don't recommend to go with 0. 0 is too aggressive. There are different problem statements we need to understand. Lot of timeline will be created in the PostgreSQL side. It creates some headaches. So I recommend 30 seconds to 60 seconds to any comfortable system to come up, restart back to the system. So I recommend to go with 30 seconds or 60 seconds, but 0 I don't recommend. Synchronous mode. Synchronous mode is one of the promotion trap, what I can say. Coming to the interesting part, right? In the PostgreSQL setup, I have one leader called PG1. I have 2 replica, and one is sync standby. We have PG2 and replica is PG3. In this case, everyone know what is synchronous, right? The write need to be committed by the primary and the sync standby node. That is the game here. And sync strict mode is on. That is the biggest challenge here. The strict mode is on. The primary also failed. The sync standby node also failed. But we have one node is up. PG3 node is up. Unfortunately, the current leader also down and sync node also down. There is no anyone to promote, or PG3 won't promote itself as a sync standby node, even though it is asyncly we configured. There is no option to promote PG3 automatically by the Patroni setup. All the write which is coming to the Patroni setup, right, it will fail actually because of the strict sync mode. So what I'm trying to say here, whenever you are configuring sync standby, I don't recommend to use synchronous mode strict on. That is what I'm trying to say. Otherwise, you need to have a very robust system or different AG to keep the sync node available. Otherwise, in any case, even though etcd is healthy, I have one node in the whole setup, I cannot serve my write request in the infra because of in uncertainty situation, but I can do my business due to this parameter synchronous mode strict on, and I have a synchronous standby node enabled. This whole game is changing and affecting the entire write operation to the system. It is very good when we are seeing that I need write need to be always successful. If write is not properly replicated to multiple node, I don't need stale data in my system. So yeah, it's good in that part. But coming to the broader picture, you are not very strict with this write commitment or something like that. So I always ask you to relook into synchronous mode strict on or off. I recommend it's off in most cases, but you are more conscious about this one. It's need to be considered. Otherwise, you need to keep your at least 1 or 2 node synchronous node count 2, or keep the say one node sync node and sync standby node in the different availability zone. So DCS unreachable and fail safe mode. I like to, this is one real scenario happened in my experience, I like to say. As I told in the initial of this talk, it's not like a Mongo or any sharded high availability setup. It's a combination of different open source solution and combined together, right? But in Mongo, right, if 2 node goes down, even 1 node I have up, I don't have a majority, the write will fail, because that is the Mongo itself holding the entire logic of Quorum, Mongo ability of things, everything. But in our case, Postgres is different, Patroni is different, etcd is different, HAProxy is different. Hope you can understand what I'm trying to say. In one scenario, interesting scenario, my all Postgres and Patroni is healthy. All is healthy. Due to some uncertainty on the etcd infra, all three node went down. All three node went down, but my Postgres and Patroni is healthy. Due to etcd became unreachable, even though my system Patroni is healthy and Postgres is healthy, my system not able to accept read and write. But within 10 minutes, the etcd came back healthier. The entire cluster came back healthier. But the 10 minutes downtime, which is not at all affordable for my client. So then what we recommended for our client, fail-safe mode, you need to enable it. So whenever we are enabling it, so when the etcd is off, when the etcd is down, the entire setup is down, Patroni do one intelligent system, which is I really excited to tell this. It do internal validation of the all other node. For example, I have a Patroni node A, B, C. I have the etcd down. If Patroni A is the leader, this A leader will validate Patroni B and C is available in the entire architecture. Then it continues the job. It won't put down any write request fail or read request fail. So that is the fail safe mode will do. So I recommend this parameter need to be handled very carefully. So whenever you need to make sure, do we need to enable no false? So, but very interesting part here I like to say, if you have a 3 Patroni A, B, C node, if C node is down and etcd also down, this won't work. In the fail-safe mode too, all the member of Patroni setup need to be up and running. It is not about 2 node up, 1 Patroni is down, then it won't work. So all the Patroni node is up, etcd is down. This will reduce your downtime, and etcd can come up and start work on their game. So there is some known bug which is reported in GH. I share the bug details and everything. There are some interesting things, you can check it. But this is always, I recommend fail safe mode on. And HAProxy. HAProxy, right? I'm from the DevOps background. I like to go a little deeper inside. So everyone explore the Patroni, like curl and Patroni URL and primary, it will return the JSON output. I like to share one interesting thing here. HAProxy is enabled through TCP, not by the HTTP protocol. In the health check, we are doing primary health check using the endpoints, REST API endpoints, but it don't read what JSON is there. That means HAProxy only rely on the 200 or 500. If I get 500, it's failed. If I get 200 written code, it is success. It nowhere read. HAProxy don't understand, don't read the JSON output shared by the Patroni. That is one important understanding we need to have here. But whether we able to achieve, we read that JSON, yes, we can do that. There we can do HTTP check, expect string, okay. We can do some homework in the HAProxy config to validate, but it is not a practice in the system. So HAProxy is more rely on the written code of the endpoint. If it is returning 503, it's failed. 2 is success. So that is one important thing. So here I like to share, there are different endpoints are there. Very important endpoint, replica lag equal to 1 MB. Since in the heavy write operation system, you have multiple replica with lag, mostly 1 MB lag is not a big number, everyone agree with me. So in case you have 1 MB lag and multiple nodes, replica nodes are not accepting the read, all nodes will be, the read will be delayed or queued and fail, lot of things come into the picture. You need to be very precise what is the lag equal to. So I recommend maybe 300 or 100 or 200 MB based on the things. So you need to be very clear on that one. So the reading the log across the layer. So I have put down the whenever something happened, you need to start you need to understand in what way you need to review the log. First, you need to understand what happened, why the log was lost. I mean the primary log. And second thing, what is the confirmation we received in DCS? Who won and how long the promotion took when the app saw the flip. So these all things you need to understand, and each service log you need to review. So we have our own aggressive logging system at MyWebinar, like Toric system. We build it by ourselves, but you can use some other open source solution to low key kind of solution to grab the log and put it to the centralized system. Whenever something goes wrong, you need to simply see what happened at the old primary, what happened in the etcd, and combine together in one Grafana kind of solution. You can easily, quickly solve the solution. But the approach, the dashboard need to be designed in such a way, like who is the current lost primary, what is it log, and what is the etcd log, what is any errors or anything, and new primary Patroni, and we have a lot of endpoints to capture when the flip is happened, those things from the HAProxy. So this need to be put together in one place so you can achieve it. So key phrases to grep, I have shared something here, you can refer it. These are all very important thing in each places to understand quickly. This why I'm sharing this important things, right? You don't need to review 50 to 100 lines of log all the time. You can grep it, or you can use some log check system to validate if something goes wrong. If you found something on the log, put an alarm to us so we will know. So you can use this and check it. Pre-failover checklist. So these are all the basic commands and everything you need to use in your Patroni management. I have shared with you. So I hope finally I come to one important things. This is my important parameter hack in the Patroni. So basically, TTL I always go with 20, loop weight come to 5, and retry always below. I always go to 2 only. Primary set zeros first, I recommend 330 only. So larger maximum lag and failure, I always go with 100 to 200 between time. So this all you need to be keep it as a reference if you need. I really, because in most of my client infra, I make sure this parameters is very clearly defined in certain way. So my engineers won't get into the problem to analyze, to find the switchover problems very to longer time. So the difference between control plane and data plane. So Postgres, whatever you are seeing in Postgres and routing, this is all data plane, control plane. This you need to visualize the system in this way. Who is control plane, who is the data plane, and everything. So you can handle very effectively which failure come under data plane, which failure come under the control plane, which part of the system I need to validate, everything. Monitor both, alert on both, understand which one is on fire. That's what I put it. I segregated in two way. Whenever something occurs, you see the mind map, right? This is all the mind map. You need to visualize when something goes wrong in Patroni, so that you can make your system back to normal very quickly. Final takeaway: what exactly triggered the promotion in what order? This all you will be as a takeaway time. The faster failover is good. A safe failover is better. A failover you understand is the best. What I like to say here. Thank you. Thank you.
So thank you so much, Manoj, for that wonderful breakdown. We just learned everything what is happening behind this Postgres failover. So thank you so much for the brilliant webinar. So all right, we will now move to the Q&A session. So attendees, if you have any questions, please post them in the Q&A or chat section. We will take it ahead. Or the mic is already open for you. you can unmute and ask questions to Manosh directly. And when you ask questions, please introduce yourself and then ask your questions. Actually, if you have a specific problem you have faced with Patroni or HAProxy, or if you are worried about your current failover speed, right? Now is the best time to ask our CTO directly.
Suppose we have 5-node cluster with the setup of Patroni. So do you have anything to do taking care of the OS level parameters along with the Patroni setup? So basically OS level parameter, some kernel tuning, CCTL level tuning, we always do, like open file limit and memory allocation. Those are very basic. And file system level, if it is XFS, we have some tuning to do our end, but nothing a game change. It's a very standard parameters we always add in our blocks and those things. Okay, is there any interrelated between the PostgreSQL config file or something which we need to taking care of that OS level? Nothing specific, Vasu. Okay. Thank you, Manosh. Thank you, Vasu. Yes,
Thank you, Vasu. So we have a question from Samit. Okay, hello sir, I'm a final year BTech CRC student. So these things were very new to me. So I have a question about the session. Was the session about database health?
Yes, Amit. Hi. Thanks for your question, and I'm very happy that you are studying your BTech computer science and joining this kind of session it's very great, man. All the best. Yeah, we talked about database health. We talk about how to handle the failovers mostly. How quickly, because failovers is unavoidable in certain cases, but how quickly getting back the system what we saw today. This is all very simple parameter, but it influence lot and improve your RTO time quickly. This is what all, if when you're serving your company, when you're serving your client, this RTO is very important in the HAProxy kind of setup. So today we saw about Patroni, etcd HAProxy config to improve the RTO time. That is what we saw today.
Thank you, Manosh. Thank you, Samit, for your curious question.
Hi, Manosh. This is Ashish.
Hi, Ashish.
Manosh, say like if that failover is happening because of network latency, in that case, if that failover is not actually because of the leader is like down or Patroni is down, if it's because of this network latency, in that case, how we can avoid such situation?
So Ashish, if it is a primary, it is a different game.
Mm-hmm.
If it is a replica, it is a different game. If it is a replica, the particular HAProxy will handle that one. The failover. If HAProxy not able to reach the Patroni setup, when you saw the parameter whenever I am explained, right, the fail count,
Yeah.
and so those count will mark the node as a failure and stop sending the connection, and it will validate back again. But if it is a if it is a primary, right, again, primary to application to primary is a different game. Patroni to read replica is different game. So where is the network break is the important things we need to understand. If it is a HAProxy to Patroni primary, the parameters again, the retry and the fails, those count come into the picture. But if it is a election, then the election will trigger, new primary got elected, this will change. But this important parameter, right, 30 seconds. If you change into 20 seconds, maybe another read replica come into the big game 20 seconds earlier and start validating the leadership lock is expired and start. This need to be improved, so your RTO time will be increased.
Okay, so in that case, probably increasing this TTL value makes sense if network latency is high.
It decrease. You need to because the 30 second is quite higher part. That's what we are talking here.
Mm-hmm.
We need to decrease it. So it look like a lot of packet is traveling between the components, but today world, it is not a big matter. So the election will happen quickly. New primary got elected, we'll change the game and we'll start serving for our application.
Okay. Yeah, all right. Makes sense. Thank you.
Thank you, Ashish.
Thank you, Ashish, for the question. We have Anbalahan dropped some 3 questions in the chat. Is etcd the better DCS option when compared to other ones?
Yeah, etcd is a lighter option. We have Zookeeper and console. etcd is quite lighter. So that is the reason most of the environment or in our infra, we highly recommend etcd, and we can easily take backup. That this talk is totally different. I didn't, mostly in our experience, no customer is taking etcd backup. When etcd goes wrong, the recovery is very bad. So etcd is a better option compared to console. We are using console also, not Zookeeper, but etcd is a quite easy and effective way of working. And DCS fail-safe mode option available. Yes, we have that. And can we set up PostgreSQL into? Yes, we can do that. To data center, we can do that. We need to optimize the configuration very effectively, and you need to understand where the application is locating, where the PostgreSQL Patroni, the different data center is locating, and even you can tell the delay node there, and those things can be achieved.
Thank you, Manosh. Thank you, Anbalahan, for the questions, engaging questions. Thank you. And thank you, Manosh, for the brilliant answers.
Sai, thanks for your question. Patroni is not a plugin. It's another component. I cannot put plugin as a right word here. It's a component. I know you are from MySQL world. Look like a proxy SQL, but proxy SQL is different. Patroni and Postgres work together in one machine or same machine, something like that. It's not a plugin. In MySQL, we enable password policy plugin, right? That is plugin. In PostgreSQL also, we have a lot of plugins, but Patroni is not a plugin.
Perfect. Thank you, Salkumar. Thank you, Manosh. So, all right. So this engagement today, it shows how committed you all are to learn more about databases and failover mechanisms. So just a quick reminder for you, we will send the slide deck and recording link to your email early next week. And please follow MyWebinar on LinkedIn for our weekly technical blogs. And if you need any help with auditing your Postgres HA setup, you can reach out to us at mydbops.com. Thank you again, Manoj, for your time. And thank you all for being such an engaging audience today. We will see you at MyWebinar 52. Have a great evening, everyone. Thank you.
Thank you.